To count how many outcomes are possible, we are going to use the concept of permutations and combinations. The multiples of 5 are 5, 10, 15 and 20 from 1 to 20. Similarly, the multiples of 7 are 7 and 14 from 1 to 20. Permutation is arrangement of n things taken or at a time, whereas the combination is nothing but the selection. There are 5 numbers 1, 2, 3, 4, 5. So using these 5 numbers, we are going to form a 3-digit number. 3-digit number means unit, 10, 100. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to discuss regarding very important chapter, that is permutations and combinations. The first part of the chapter is permutation and the second part is the combination. So the weightage for this chapter is 7 marks. So now what are the things we are going to study in this chapter? So the weightage for this permutation and combination is, so you are going to get 7 marks from this, 1 mark, 2 marks and 3 marks question. That's all. No 5 marker question. Now, so in this session, I am going to discuss regarding the introduction and then fundamental principles of counting and the representation of a number, that is a factorial representation, permutations with repetition and without repetition. So permutations with repetitions and without repetition, formula for permutations and simple problems based on this. So what are the things I am going to study in this session is introduction for this, and then the fundamental principle of counting, factorial notation and permutations with repetition and without repetition, and also the formula for permutations as well as the problems based on this. Now let us move on to the first. So what is this permutation and combination? So permutation and combinations are the ways to represent a group of objects or digits or letters. So just permutation and combination is nothing but the way of representing. It is nothing but represent a group of object or digits or letters. So representing the group of objects or digits or letters is nothing but the meaning of permutations and combinations. Now these are the methods employed in counting how many outcomes are possible. So to count how many outcomes are possible, we are going to use the concept of permutations and combinations. So permutations are nothing but the arrangement of elements. The arrangement of n elements taking or at a time is called the permutation, whereas the combination understood that is nothing but the selection. So combination is the selection, permutation is the arrangement. So permutation is nothing but arrangement of elements, whereas combination is nothing but the selection. So that is the meaning of permutations and combinations. Let us take an example for permutations and combinations. My fruit salad. Fruit salad is the combination of apple, grapes and bananas. My fruit salad is a combination of apple as well as grapes and bananas. Next, consider the 3 letters X, Y and Z, taking 2 letters at a time. Let us take any 2 letters at a time. So there are 3 letters X, Y and Z, taking 2 at a time. You can form 3 groups. The 3 groups are X, Y, Y, Z and Z, X. These are the 3 groups X, Y, Y, Z and ZX. But it can be arranged in 6 different ways, like X, Y, then Y, X, Y, Z and Z, Y, Z, X and X, Z. So this can be repeated. This can be just interchanged. That is X, Y, Y, X, Y, Z, Z, Y, Z, X, X, Z. So like this we are going to arrange in 6 different ways. So 3 letters X, Y, Z taking 2 letters at a time can be formed in a group, 3 groups like X, Y, Y, Z and ZX. But it can be arranged in 6 different ways, the arrangement. So here the combination one is the arrangement. So that is arranged in 6 different ways like XY, YX, YZ, ZY, ZX and XZ. Okay. Now move on to the next, factorial notation. This is very important concept, factorial. For example, find the value of 7 factorial minus 4 factorial. So how to find 7 factorial minus 4 factorial? Now So, you know the factorial of 7 is equal to 5040. Here it is 24. Subtract this. 5040 minus 24. What is this equal to? So, 40 minus 24 is 16. 5016. That's it. Okay. Now, let us move on to the next concept. Fundamental principle of counting. This is very important concept. So, the sum rule as well as the product rule. So, we have sum rule first. So, the fundamental principle of counting, first one is the sum rule. What is the sum rule? If one operation can be performed in m different ways, if one operation can be performed in m ways and the another operation can be performed in n different ways, another operation in n ways. So, one operation in m ways, another operation in n different ways, and the two operations are mutually exclusive, then either of the two operations can be performed in, just add this, m plus n ways, right. So, this is called the fundamental principle of counting, that is nothing but sum rule. So, the fundamental principle of counting, in which the sum rule is, if one operation can be performed in m different ways and another operation can be performed in n different ways, then the two operations are mutually exclusive, then either of the two operations can be performed in m plus n ways. Now, let us take an example for this. Now, for example, in how many ways can choose a number from 1 to 20 which is a multiple of 5 and 7. Now, in how many ways we can choose a number from 1 to 20? They are the multiples of 5 as well as multiples of 7. Okay. Now, let us write the multiples of 5. So, from 1 to 20, the multiples of 5 are 5, 10, 15 and 20. There are 4 numbers. If 20 is the number, then the multiples of 5 are 5, 10, 15, 20, right. 5 ones are 5 twos are 5 threes are 5 fours are. So, there are 4 numbers. Similarly, find out the multiples of 7. Multiples of 7 are 7 and 14. So, only 7 and 14 are the multiples of 7 in between 1 and 20. So, the multiples of 5 are 5, 10, 15 and 20 from 1 to 20. Similarly, the multiples of 7 are 7 and 14 from 1 to 20. So, m is equal to 4 and n is equal to 2. So, according to the principle, the total number of choosing the number is equal to m plus n, that is nothing but 4 plus 2, that is equal to 6. This is the fundamental principle of sum, that is called the sum rule. Now, let us move on to the next one, product rule. What is this product rule? If one operation can be performed in m ways and another corresponding operation can be performed in n ways, then the two operations can be performed in mn ways. Suppose one operation can be done in m ways, another operation can be done in n ways, then the two operations can be performed in m into n ways. This is called as the product rule. One is the addition rule. In addition rule, m plus n, whereas in the product rule, m into n. Now, let us take a problem on this. Take an example. Now, for example, a die is cast and then a coin is tossed. Find the number of all possible outcomes. A die is cast and so a coin is tossed. You are going to toss a coin. So, a die is thrown and a coin is tossed. Find the number of all possible outcomes. So, you know, in a die it is numbered as 1 to 6, 1, 2, 3, 4, 5 and 6. Whereas if you toss a coin, what are the possibilities? You may get a head or a tail. How many events? 2 events. So, if you throw a die, the possible number of events are 6. Whereas if you toss a coin, then the possible number of events is 2, head and tail. So, here let us represent this as m. m is equal to 1, 2, 3, 4, 5, 6. So, m is equal to 6. And tossing a coin, n is equal to head and tail, that is equal to 2. So, therefore, the total outcomes are nothing but m into n, that is equal to 6 into 2, that is equal to 12 ways. That is it. So, one is the sum rule, another one is the product rule. Now, let us move on to the next one. What is the permutation? Now, let us come to the permutation. What is the permutation? Definition of a permutation. And how we are going to represent the permutation. So, the term permutations refers to a mathematical calculation of number of ways a particular set can be arranged. The arrangement of numbers, that is number of arrangement, is called the permutation. That is The number of ways a particular set can be arranged is called the permutation. Suppose if there are n numbers, so n numbers, by taking r at a time, how we are going to arrange? That is nothing but the arrangement of n things taken r at a time is called the permutation of NPR, that is denoted as NPR. The permutation of n things taken r at a time is called a permutation of n things taken r at a time, and it is denoted as NPR. That is, but simply a permutation is a word that describes the number of ways of things can be ordered or arranged. With permutations, the order of the arrangement matters. So that is, simply it is nothing but the number of ways of things can be ordered or arranged. Now, what is a combination here? The combination is nothing but the selection. Permutation is arrangement of n things taken r at a time, whereas the combination is nothing but the selection. The selection of n things taken r at a time is called the combination. The combination is a selection of a part of the set of objects or a selection of all the objects when order doesn't matter. If the order doesn't matter, the selection of all the elements or part of an element is called as the combination. Therefore, the number of combinations of n objects taken r at a time is denoted as NCR. So, first one is NPR, the permutations is denoted as NPR, whereas the combination is denoted as NCR. That means, so here NPR represents number of permutations of n things and taken r at a time. That is, the arrangement of n things taken r at a time is called the permutation. The selection of n things taken r at a time is called as the combination. One is the arrangement, another one is the selection. Now, move on to the small example. How many 3 digits number can be formed using the first 5 natural numbers? So, the first 5 natural numbers are 1, 2, 3, 4 and 5 are the first 5 natural numbers. So, using these 5 natural numbers, how many 3 digits number can be formed? Now, listen, just how many 3 digits numbers can be formed using the first 5 natural numbers? Here the condition. So, here the repetition allowed or may not be allowed. Listen, first suppose if the repetition is allowed. So, here 3 digit number. So, 3 digit number can be formed like this. So, here it is unit, 10 and 100 place. Unit place, 10th place and 100 place, right? So, to form 3 digit numbers, unit place can be filled in 5 ways, and similarly 10th place can also be filled in 5 ways, and the 100th place can also be filled in 5 ways. Here, so there are 5 numbers 1, 2, 3, 4, 5. So, using these 5 numbers, we are going to form a 3 digit number. 3 digit number means unit, 10, 100, right? So, in the unit place, all the 5 numbers can be placed. Even in the 10th place, all the 5 numbers can be placed, and even in the 100th place, all the 5 numbers can be placed. So, in this way, we can write 5 into 5 into 5. That's equal to 125 ways. 125 ways. That's it. Okay. If there is a repetition, suppose if there is no repetition, if no repetition is allowed, no repetition. If no repetition is allowed means very simple. So, the unit place can be filled in 5 ways, unit, 10 and 100, and one element is gone. Then remaining 4 can be placed in the, that is 10th place, and the remaining 3 can be placed in 100th place. So, that is unit place can be filled by 5 numbers, if that is if there is no repetition. So, then the 10th place is replaced by the remaining 4 numbers, and whereas the 100th place can be filled using the remaining 3 numbers. So, therefore, the number of ways when there is no repetition is 3 into 4 into 5. 5 4s are 20 into 3 is 60 ways. This is with repetition and this is without repetition. That's it. So, here it is unit place, 10th place and 100th place. So, all the 5 numbers can be accommodated in this 100th place. Suppose if we take all the 5 numbers in the 100th place, the remaining 2 places, so one element is gone, then the remaining 4 can be filled in the 10th place, and one element is taken out, then the remaining 3 can be filled in unit place. So, 5 in 100th place, 4 in 10th place and 3 in unit place. So, therefore, the required number of numbers is equal to 5 into 4 into 3, that is nothing but 60 ways. So, one is with replacement, another one is without replacement. Okay. Now let us move on to the next problem. In how many ways 3 books can be placed next to each other on a shelf? Now, very simple. In how many ways 3 books can be placed next to each other on a shelf? So, the first book, one book can be taken in 3 ways, and the second book can be taken in 2 ways, and the third book can be taken in 1 way. So, therefore, the total possibilities, the total ways are 3 into 2 into 1, that's equal to 6 ways. So, in 6 ways we can arrange. So, in 6 ways we can place the books in a shelf. Now, move on to the next problem. Next, the number of permutations of n elements with repetition is n to the power of r, that is n into n, r times is nothing but n to the power of r. Now, that is number of permutations of n elements. Number of permutations of n elements with repetition is n to the power of r. The number of permutations of n elements with repetition can be written as, can be calculated using n to the power of r. Whereas that is n into n, r time is nothing but n to the power of r. Similarly, the number of permutations of elements without replacement is nothing but n factorial. So, without replacement it is n factorial. Then the permutation with replacement is n to the power of r. That's it. Okay. Move on to the next concept, formula to find the permutation. So, NPR is denoted as, how to find the permutation of n different things taken all at a time, that is denoted as NPR. NPR is equal to n factorial divided by n minus r factorial. So, the permutation of n different things taken all at a time is denoted as NPR and is given by n factorial divided by n minus r factorial. Now, let us take for example, 4p3. 4p3. So, the value of 4p3 can be written as 4 factorial divided by 4 minus r is 3 factorial. That's equal to factorial 4 divided by factorial 1. That's equal to 4 into 3 into 2 into 1. 4 3s are 12, 12 2s are 24. Now, let us take one more example. Suppose if you want to find the value of 4p4. 4p4. So, here this is nothing but factorial 4 divided by factorial 4 minus 4 factorial. That is factorial 4 divided by 0 factorial. That's also equal to 4 factorial is 4 into 3 into 2 into 1 divided by 1. That's equal to 24. So, 4p3 is nothing but 4 factorial divided by 4 minus 3, that is 4 factorial by 1 is same as that of 4p4. That means here npn is always equal to n factorial. Npn is equal to n factorial. Right. Now, move on to the next one. Take an example. For example, 10p3 and 8p4. Now, 10p3 can be written as 10p3 is equal to factorial 10 divided by factorial 10 minus 3 factorial. Factorial 10 divided by 10 minus 3, 7 factorial. This is 10 into 9 into 8 into factorial 7 divided by factorial 7. These two gets cancelled. Multiply this. So, 10 into 9 into 8. That's nothing but 8 into 9, 72 into 10 is 720. That's it. 10p3 is nothing but 10 factorial divided by 10 minus 3. That is 10 into 9 into 8 into factorial 7 divided by factorial 7. 10 into 9 into 8 is nothing but 720. Now, move on to the second one. What is the second one? 8p4. 8p4. So, this is factorial 8 divided by 8 minus 4. So, 8 factorial divided by 4 factorial. 8 factorial means 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial. These two gets cancelled. Now, what is left? 8 into 7 into 6 into 5. Simplify this. That's all. See here, multiply this. 5 into 6, 30 into 7, 210 into 8. 8 into 210. 210 into 8. That's equal to 1680. That's it. Right. So, this is how we are going to find the value of 10p3 and 8p4. Now, move on to the next one. This is a very important problem. Find n if np3 is equal to 210. np3 is equal to 210. np3 is nothing but n factorial divided by n minus 3 factorial is equal to 210. Okay. Now what is this equal to? So n, this is nothing but n factorial means n into n minus 1, n minus 2 into n minus 3 factorial divided by this denominator n minus 3 factorial is equal to 210. N minus 3 factorial, n minus 3 gets cancelled. What is left over is n into n minus 1 into n minus 2 is equal to 210. Now let us assume n is equal to 7. Suppose if n is equal to 7, then this can be as 7 into 7 minus 1 is 6. 7 minus 2 is equal to 5. What is this equal to? 210. So therefore the value of n is equal to 7. That's it. There are on trial method. So if you put n is equal to 7, 7 into 7 minus 1 is 6, 7 minus 2 is 5, 5, 6 are 30, 30 into 7 is 210, which is the required answer. Otherwise, you can factorize it and get the answer. Okay. Now the value of n is equal to 7. Now let us move on to the similar type problem. If np3 is to np2 is equal to 3 is to 1, find n. This is also an important problem. If np3 is to np2 is equal to 3 is to 1, find the value of n. Now what is given? np3 divided by np2 is equal to 3 by 1. Okay. Now what is the meaning of this np3? That is nothing but n into n minus 1 into n minus 2 divided by n into n minus 1 is equal to 3. So n into n minus 1 gets cancelled. N minus 2 is equal to 3. N is equal to 3 plus 2, that is equal to 5. That's it. Very simple here. np3 by np2 is equal to 3 by 1. So np3 is n into n minus 1 into n minus 3 divided by np2 is n into n minus 2 is equal to 3 by 1 is 3. That is n minus 1, n gets cancelled, n minus 2 is equal to 3. Therefore, if n minus 2 is equal to 3 means n is equal to 3 plus 2, that is n is equal to 5. The required answer is n is equal to 5. That's it. Okay. Now move on to the next problem. If pi PR is equal to 60, find the value of R. Now listen, what is given? If pi PR is equal to 60, pi PR can be written as pi PR is equal to 60 means 5 factorial divided by 5 minus R factorial is equal to 60, right? So here, very simple. You know what is the value of 5 factorial? 5 factorial. Factorial of 5 is 5 into 4 into 3 into 2 into 1. So 3 2s are 6, 6 4s are 24 into 5 is 120. 5 4s are 20, 20 into 3, 16 into 2 is 120. So here it is 120 divided by, bring this to the denominator, 60 is equal to 5 minus R factorial. So 120 by 2 is nothing but here it is 2 is equal to 5 minus R factorial. So therefore R is equal to 5 minus 2, that is equal to 3. The value of R is equal to 3. That's it. So here the value of R is equal to 3. That's it. Hope you followed. 5 minus R factorial is equal to 2. Therefore R is equal to 5 minus 2, that's equal to 3. Now move on to the next problem. So in how many ways 5 people stand in a queue? In how many ways? Only 5 people. 5 people can stand in a queue. Now just in how many ways 5 people can stand in a queue means this is nothing but the permutation. So permutation of 5 members taken 5 at a time, that is nothing but 5p5. So what is 5p5? That is nothing but 5 factorial. So 5p5 is nothing but 5 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1, that is nothing but 120. That's it. So in 120 ways 5 people can stand in a queue. Now move on to the next problem. How many 3 letters word can be formed using only the consonants but each only once? So using the consonant 3 letters can be formed only once, each element has to be taken. So the number of consonants are 21. So therefore the total number of 3 lettered words can be formed using is 21 into 20 into 19, that is nothing but 7,980. So number of consonants are 28. So we are going to form 3 letter words in 21, all the 21, then 20 into 19, that is equal to 7,980. Now the next problem. In how many ways can 7 mathematics books, 8 statistics books and 4 accountancy books can be arranged in a shelf if the maths books are always together? So how many maths? So math books are 7 and 8 stats books are 8 and then 4 accountancy book. So totally how many are there? 7 plus 8. So that is 15 plus 4, 19 books are there, right? Now here consider the 7 maths book as 1 unit. Consider it as 1 unit. The number of permutation of n unit, that is 7 maths books plus 8 stats books and 4 accountancy books. The total number of items are 19. That is 8 plus 4 plus 1 is total. There are 13 items. So that can be 13 factorial. For each of these arrangement, the 7 books can be arranged in 13 into 7 factorial. 13 factorial into 7 factorial ways. So let us consider all the mathematics books as 1 unit. Then there are 8 stats books and 4 accountancy. 8 plus 4 plus 1 is nothing but 13. And whereas how many mathematics books? 7. So therefore, for each of the arrangement, the 7 books can be arranged in 7 ways. So first one is the 13 ways, another one is the 7 ways. Therefore, the total number of arrangement is 13 factorial into 7 factorial. Next, how many different arrangements can be made with the letters of the word Monday, right? So this is very simple problem. How many letters are there? 1, 2, 3, 4, 5, 6. So n is equal to 6. So totally there are 6 letters. M, 1 M, and how many O? 1 O, N, 1 N, then N is 1 D, 1 D, and A. All are different. 1 time. All letters are 1 time. M, O, N, no word is repeated, no letter is repeated here. Okay. So here very simple. So 6 numbers are there. How many different arrangement can made with the letters of the word Monday? So that is 6 into 5 into 4 into 3 into 2 into 1, that is nothing but 720 ways. So these are the total number of arrangement of the words. Now move on to the next. How many different 4 digits number can be formed using 1, 2, 3, 4, 5, 7, 8 and 9? No digit being repeated in any number, right? No digit, that is without repetition. So what is given? The 1000 place can be filled in 7 ways. For each of these, the 100 place can 100 10th unit places can be filled in 6 and 5 and 4. So therefore, the total number of possibilities are 7 into 6 into 5 into 4, that is 840 ways. See here. So here, how many different 4 digits numbers can be formed using the digits 1, 2, 4, 5, 7, 8, 9. No digit being repeated in any number. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7 numbers are there. Here n is equal to 7. So that means in this 7, so we are going to place unit, 10, 100 and 1000. How many different 4 numbers? 4 digit number means unit, 10, 100, 1000, right? So that is the 1000 case can be filled in 7, the 1000. For each of these 100 place can be filled 100, remaining 6, and again 10 places can be filled by the remaining 5, and the unit place can be filled by the remaining 4. So that is unit, 10, 100 and 1000. So if you multiply, you will get the answer. The total ways is equal to 7 into 6 into 5 into 4, that is nothing but 840 ways or 840 numbers. Now the last problem. How many 4 digit even numbers can be formed using 1, 2, 3, 4, 5, 6, no digit being repeated? So how many digits are there? 1, 2, 3, 4, 5, 6. So n is equal to 6. So even digit, how many even digits are there? 2, 4 and 6, right? So here, if the number is even, it has no end with even number, hence the unit place can be filled in 3 choices, and the 1000 and the 100 and the 10th places can be filled in 5, 4 and 3. So therefore, the 4 digit numbers can be formed using 5 into 4 into 3 into 3, that is nothing but 180. Because so here the unit place has 3 choices, and the 1000, hundreds and the 10th places can be filled in 5, 4 and 3. So therefore, the 4 digit even number can be filled in 5 into 4 into 3 into 3, that's equal to 180. That's it. Okay. Hope you followed. So these are few simple examples for the permutations and the factorial representation. So hope you followed. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.